Hi and welcome. So I'm finally back with a tutorial that is not about the infection solver, which I hope you checked out, that we released a lot of videos on. But today we would rather gonna jump into some low-level dark mantra stuff. And I'm quite happy about this because there are no other videos about this. Actually there is one old Peter Quint video that is I think 15 years old or something that covers some of this a little bit. But not really what we're gonna go through today. So what we're gonna talk about is the Illuminance and Gather Loop in Vex shading. And what we're gonna try to do is something similar to an outline shader. And I don't know if you ever tried to build a toon shader in Mantra or Redshift or whatever, and what you will find is that it's kind of missing some kind of quite important stuff like a good outline, etc. There is one solution that I use that is a displacement of the whole thing that you put behind, but that's not really convenient and not really giving you the result you might need because you only get like the big outlines. So in order to do this, we're first going to look at some a bit more custom Vex VOPs in shading. And these only exist in this context because they use rays, etc. And you could of course do this in VOP as well, but it's not really the same thing. So I'm just going to start off quite simply with dropping down, we can start with a pig head. And we're going to do no shader, and we're going to subdivide it. And this is not the simplest things. You should have a good understanding of things before you do this, because yeah, it's kind of a bit tricky stuff here. So I'm just going to put down point normals as well. You could do vertice normals, but I'm just going to do point normals because I think it's easier. And we're going to put down a material, and we're going to create our materials just upon shop network and do a material shader builder. And we're just going to link this to the material. And I'm just going to do a temp save here on my temp folder. So yeah, and then we can jump in here. So when we're in this context, hopefully you recognize this, and you have all these global inputs and you have these global outputs. It's not very hard. So what we can do now is we're going to look at two different loops, and the first one is the luminance loop. So what the luminance loop is that it loops over all lights, and then it checks for each polygon if its normal is within, if the normal direction towards the light is within a given angle, and if so, it does something with the micropolygon that's hit. So to do this, we would need to add a light as well. So we're just going to back up and add a light. And what's a bit confusing here is that one should understand that so like a point light, how do you know if you hit it? So what it does is rather it looks within a cone to see if it's hit. So it doesn't, you can use a point light or an area light or whatever, it doesn't really matter. It's just going to put an area light here. And what we can do now is we can put down the Illuminance loop. And we have it here. So this is a bit odd. What you see on the start is just this, you have no outputs, and that's because it's a loop, you have to jump in it. So what we can do is we can start off with just adding the position to the position, the normal to normal, and don't use the NG because that's like the hard normal kind of. And then we also have angle, and what we can do here is we can add a constant. And this is the angle in radians that the micropolygon will look for lights in. So if we just want this to 90 degrees, which is what you usually want, then you can do just $pi and divide it by 2, and then you get the 90-degree radius. And then this works a bit odd because you also have this next here. And how this next works is that this is attributes you will work with, kind of. And what we want to do here is we want to have our surface color And I guess that's just what we need now. But then we also want to put out a value. And in order to do that, we just do a constant here. And we can call this like total illumination or something. And we'll plug that into the next as well. And when we've done that, we can jump in here. And what we see now is we have this surface color and we have this total illumination. And what we also can get in this context is a bit different things. So if we've done a global variable, now that we're within the Illuminance context, you have a few other outputs. I choose light here, but it doesn't really matter. You can get it anyway. So what we can get here as well is the light color. So how does this work? So if we just plug in total illumination to total illumination here, you will see that we get this out. So if we plug that in there, save, try to save a lot, and just go, we're gonna create a camera as well. Can do that, new camera, and go to render view and hit render. We will see that stuff is happening. Takes a while, apparently. We get nothing. So why do we get nothing? Well, because we have a constant going in here and we have a constant out. But if we were to, in here instead, just take the light of the color, plug it in total illumination, you see that we get this. So basically what it does is the black ones here are those with outside the angle. So if we go here and would increase the angle, we can say pi instead, so we get a 180 degree, you will see that we get everything shaded, basically. So we just get the light color, and you see with the light color we also get a fall off. And one thing you might notice as well, that we have no shadows. And that can be handled quite easily. We have a shadow bop here as well. So we plug this in, you will see that we also get the shadows. So this can be quite simple. You can just use this in order to do things for each light. So one thing you probably want to do as well is you also would like to multiply this with the surface color. Now the surface color is white, so it doesn't matter, but it could be another color. And then you get a super basic shading. You don't get really shading, you just get the light and what light hits. But this is a good starting point for a lot of things. And yeah, it's kind of nice to have that kind of option. And this, of course, also works. So if you would change the light color, you also get, oh, no, we just have a, we should also change so we have this as a vector, not as a, so you see with total illumination. So what we could do here instead is we can do this as a vector, and now you see we get a green pig. So yeah, this is quite simple. And it's not simple, but it's nice to know. And what you can do here is, of course, you can also like do very simple things. You can like you can bring in other things here as well. So if you were to bring in like eye, which is the position of the camera, bring that into next, and then we could like do the dot product of the normal and the eye, and we can do that absolute maybe. So we just get positive numbers, and then we can multiply this as well, and you plug that in. Okay, we get nothing here. Why is that? We get the eye. Okay, we have normal in. We should get something here. We get nothing. Eye and normal might. So let's see here instead if we do. I have the normal. Bring the normal in. Let's bring in the eye, which is the direction from the eye to surface. Let's try that instead, sorry. There we get something, yeah, sorry. We get, though they have the same direction, sorry, my bad. So you could do something like this instead if you want to. I don't know the reason for it though, but as you can see, you get this kind of Fresnel, reverse Fresnel effect. Okay, change this, you can see the difference. So you can do those kind of things as well if you want to get kind of a specular effect of this. So you have all these options here. But yeah, this is just base for the luminance loop. And what you would do if you would like do more advanced thing, you would then put the gather loop, which we're going to talk more about, inside this illuminance loop. So you loop over each light. So if we were to add another light here, it would add another loop. So I can just do another light here, maybe. I'm just gonna see where it is. We have a light inside him, but if we were to move this there, you will see here that we also get that kind of light. But you don't really get that nice shading from it. I could also remove this kind of idea with the eye and the VOP thing. Just plug this in here. So what you get here is very basic kind of thing. But what we do now as well is that we use the CF and we multiply this. So what we would like to do as well then is to have the total illumination instead. And sorry, we would like to, just gonna think for a second. So what we want to do is this, and we can go back here, and then we would like, just gonna remove this dot product thing because it's not really necessary here. So what you would like to do then is you would like to add this, because this is a loop. So for each iteration, you would like them to be additive instead. So what you would like to do if you do something like this is that you add the total illumination. So how this works is that each iteration, which is once for each light, you can see now that we get a more reasonable shading. So what it does is that for each light, it takes the total illumination and it adds the light with the shadow to this, and then it iterates for the next one, and then it has that total illumination, it adds this to that. So you get like this, yeah, and that's just because of the fundamentals of a loop kind of thing. So that's how you would go about that. But let's look at something that's a bit more useful. So I'm just gonna do another material here instead. So if we have another material VOP here, and this one we're gonna do a gather thing in order to get the outlines of this. So it's gonna change to my new material here. We could rename them as well, so we can call this gather, and we can call this simple Illuminance loop. Gather. So in the gather, we want to do something a bit different. So what we want here is we want to look at each pixel, and in order to get an outline, we would like to see pixels around it and see how they differ in position, kind of. So in order to do that, we can send out rays from the camera position, and we can vary them a little bit. So we send out rays to a pixel and also the adjacent pixels and compare those two. And this is a bit more complex, but I hope that after this you will have a basic understanding of how it works. So let's start with looking at the gather loop. So how this works is that it sends out rays for every sample, so to speak. So this needs some things. It needs a position, and it needs the direction of where to send rays. It needs an angle of how big the cone is that you're gonna send rays from this direction, in this direction from this position. It needs samples, which is basically the amount of rays. And the bias and max distance we can leave at this, but you can of course change them as well. Bias is by default 0.05, I think, and the max distance is by default unlimited. And then scope is in order to like a filter of what you want to do this with. So first off, so we're gonna think about this a bit differently. First thing we can do is we can just disable the lights, because we don't need them anymore, because this is something that's not based on lights. So that's why we don't do the Illuminance loop either. So the gather works in a similar way as the Illuminance. We will have input and we will have an output. But we have some very unintuitive, a bit complex things here as well. So we can first off start with the position. So the position is not the surface position, which we have here, but we would rather want the position to be the camera position, because it's from the camera position we want to send out rays. So we start with doing that. And then the direction. And the direction we want to send rays is the direction from the eye to surface, the eye vector. So we're going to normalize that and plug that into the direction. The angle we want a constant for, so we're just going to do a constant here. And we're gonna set it off to something quite small, something like 0.1. And this is actually the how wide our outline is gonna be. And after that, we can skip the bias, max distance, and etc. Oh, yeah, we want samples as well, of course. Sorry. So we're gonna do another constant. It's gonna do a constant here. We're gonna do that as an integer. And we're going to start off with 10 samples. If you don't plug in anything to samples, just do one sample. So, but then we have a few quirks here. And you can see we have an import here. And that says CF now, which is surface color. We don't want surface color here. But what we would want is the ray length. And this is a bit complex. So when we have imports 1 here, that means that the first next we will plug in here will be imported from the ray. If we have 2, the first 2 ones will be that. And that's kind of hard to grasp. It's not very hard to grasp, but it's kind of quirky and it's hard to understand if you don't like know it. So what am I going to do is I'm going to do a constant that's called ray length. And I'm going to plug that into the next. And then I'm going to change the import here to ray length. Okay? But what I also want to do is I also want to store the ray length for each ray. Because the ray length here will be how far, because we have the hit on the surface, and then we do a cone, so we sample between it. So if we can store all the ray length that we send out, that can help us. So what we're going to do here is we're going to do another constant for this one. There's a lot of plugins, in-plugs here. And what we want here is actually an array float. So we're going to do a float array. And we're going to call this like out. We do small. We call it just, sorry, we just call it length. Sorry. And then we will store all the ray length here. So eventually we will need also the normals. We're going to start with this just to get started so we don't confuse things too much. What we're going to do then is we're going to jump in here. And what we get now is that for each ray that's been sent out, we do an import that's ray length. So this attribute will be overridden with this. So what we can do then is we can take the length here, which is an array, and we can append the ray length. And then we can put it out as length. So what we get now is this out. And what we get is for each sample, we get 10 arrays, or 10 length of the arrays of the adjacent hits. And the adjacent hits is based on this angle. So it does a radius of 0.01, and it sends rays in a cone with this variance. And then it stores the length of those rays. So on the air here, we will get, hits that doesn't hit. And this can't really handle missed rays, which is kind of annoying, but it still works as we want it to, kind of. So what we want to do now is we want to calculate how far the least traveled ray and the most traveled ray has gone. So how we do that? Well, we can do it with a snippet. And the snippet works similar to how the loops work, in the sense that you have to plug in whatever you want to plug out. And so what we want to do here as well is we also want to plug in a value here, and that value will be our shading value. So we can do another constant here, and we can just call this value, for example. So what we will have here is the length and the value. So now we just need to write some code to get this to work. So what we're going to do is we're going to do a for loop. I don't like for each loops. I know it's more efficient, but I don't like it. So I'm just going to do a length. So calculate how long the length is. So I'm just going to do. And the thing is here, when we plug this in, we don't need to do a global declaration stuff and things like that. We can just reference this as a length. So everything you plug in here, we can just reference as it's been declared already, kind of. And it's when we do this, that will be the value that comes out here. It's called out value. So we have the length of it here. And we also want to do a min and a max. So I'm just going to do float min. do a float max, but since this doesn't need to be output, we can just do it like this. And then we can do a for loop. So we do for int I is 0, I is less than len, and I plus plus for each iteration. And I assume that you know how for loops works, because, I mean, sorry, but you would need, if you don't know that, I don't think this is for you, sorry. And we're just gonna first check if it's the first iteration, so if I is equal to 0, then we just do min is equal to out. Oh, sorry, it's just. Why is it now called out length? That's weird. Okay, so then it's if we're on the first iteration, we're just going to store the min and max as this. So what we can do is min is equal to out, not out, sorry, length I, and the same thing with the max. So for the first iteration, we store these values as min and max. And yeah, there we go. And then we just check the other race. So we can say if length I is smaller than min, then min is equal to length I. And then we do the same thing for the maximum, but the other way around. So if length I is bigger than maximum, maximum is equal to that amount. Cool. And what we can do then is we just say value is equal to max minus min. And hopefully we will now see that this gives us something. It always takes time to set it off, but then it's usually quite fast. So what you see here is we get these kind of things. We get nice outlines where it's, and what we can do then is, of course, we might wanna like refit this. So what we can do is we can also put in a fit node, because this is, you see, it's a bit similar to what we get from a Fresnel, but it's a completely different way of calculating it, and it gives us a quite nice result. So I'm gonna do like this, and I'm gonna do like 1 and 0. What the fuck? This looks weird. Maybe it's too much. Maybe we need to be like this. Yeah, lower right like this. So what we get now, maybe we can bring this up to. There we go. There we start having nice outlines. But we still get a little bit of Fresnel effect. I'm just gonna put in a background here. So what I'm gonna do here is I just, in order to see things, so I'm just gonna do a grid. Just gonna stop this. I'm gonna go here. I'm gonna do a grid. I'm gonna lay it down in XY plane is correct, or X like that. Gonna move it back a bit. Just gonna make it a little bigger. Okay, gonna rotate 180 degrees so we see it like this. So we have a grid here, and then I'm just gonna set that to camera. Okay, so we need to move it further back, I guess. There we go. Okay, maybe make it like really far and make it bigger. So, and then we just like this. There we go. And then we can just do a material for this as well. I can put it, just to be simple, we put it within this sharpnet. So it's gonna material, but we can just do fuck it, we just do a constant. Just gonna do it a color, like do it like yellow or something. I'm just gonna reference that. Sorry, just used Redshift, so I'm kind of confused. So we have a constant there. Cool. And if we go to render view now, we should be able to see the general outlines as well a bit better. So what you see now is we have quite nice shaders, outlines. And of course this can be tweaked, and this gives us a lot nicer result than the Fresnel does. So that's just a way of using it. But if we want to fine tune this, we can do that quite simple as well. See what happens if we bring this down. And what we can do now as well is we can, of course, then also choose the angle. A smaller angle gives us smaller outlines, and a bigger angle gives us bigger outlines. Okay, that's too much. Okay. Okay. Too big. We need to get it down. Yeah, but maybe like that. Oh, that's too big as well. Yeah, super big. And yeah, but we want to bring this down. And what we can do as well is we can also increase the samples to get a nicer, so the small details can kind of go away when we have too small angles. So what we can do is we can bring up the samples like 30 instead, and that gives us a little bit more definition on the small angles. And you can see this quite nice actually. It's a lot better than a Fresnel. But you can still get some kind of Fresnel effect, especially if we change this to the rubber toy instead. We just plug in the rubber toy, and if we just see here the angle, as we go something like this, so we get a really Fresnel-y angle there. You see we start getting this kind of crap, which is still not as problematic as it is with the Fresnel shader. I can show you that. I showed you that earlier. So how can we fix this? Well, quite simply, we can use the same gather loop, but we can also start looking at the adjacent normals. So if the adjacent normals is similar to the ones we're shading, we give it nothing. So how we do that? Well, what we want then is we want to import the normal as well into this. So right now we have ray length and we have length. So what we need here, and this is tricky part. So since if I were to increase this, we're going to stop this and we're going to increase this to another import. So what happens now is that it looks at input 0 as this, and it looks at ray length as this. So that doesn't really work. So first thing we can do is do like that instead, so we get it after. But then we would need to remove the length here, and instead we would need to plug in what we want to import here. So what is that? Well, it's basically normal. So we can do a constant here. Just do it as 3 vectors and plug it in, and we can call it surface normal or something. Surface n is nice. So we have those two, and now when we import the second one here, we can basically just write n, and then it support the n on the surface. And you have all these presets here, but you can also import regular attributes. That's convenient. What we want to do then is we want to plug in the length again, so we have that, but we will also need an array for all the normals. So you can do a new constant, and I'm just going to do this as a vector array. So we do free float array, vector array, we got it there, and we plug it in there, and we can just call this normals or something. So now we have all of these. So what we need to do now is we need to append the normal as well. So this is not really working right now because this is weird. We remove that. So we have the ray length there and we have the length there, which is good. And then we do another append here. So what we want to do is we have a normals array and we want to append the normal. And then we're going to store it out as normals, and this one we're going to store out as length and not surface normal. So now we have the normals saved for each ray as well. Just going to plug this in here. So we're going to do another snippet then. And that snippet needs to look at some few other things. So I'm going to do a snippet. And we want a value out as well, so we can plug in the value here. But we also need the normal array, so we're going to plug that in. And we also, I think we also would look at the regular surface normal, which comes here. And then we also would like to look at the number of samples, I think. So I'm just going to plug that in as well, so we have the samples in here. So what we're going to do now is we're going to do something similar. So we're just going to do an int len is equal to len underscore normals. And that gives us the length of the normal array. And then we're going to do, I don't know, I was going to think here, how do we do it? We just need a max value here, I think. So we're just going to do a float max is equal to 0. And then we're going to have to do a for loop. So we do for int I is equal to 0. I is less than len and I++. Could, of course, write this in a simpler way. So then we're just going to do a vector. So we're going to say vector, you can call it nor for normal, is equal to out normals and I. And then we're just going to calculate. We shouldn't call it max, we should call it sum maybe instead. Just going to call it sum. So we're just going to add sum is plus equals to the absolute of the dot product of the normal coming in, which is just called n, and the nor, which is the ray normal. Hope you're with me still. And that's pretty much it. What we get now is how big difference there is within the rays. So since we have a value in here, we can just say value is equal to, maybe fit this. So we're going to fit the sum. And we're going to say like a minimum value should maybe be, I don't know, I just set the value. I say 20 and then I say samples because I think we brought it up to 30 samples. So I'm just going to do samples and I'm just going to do 0 and 1. And what that hopefully will give us is something like this. Let's see here. Okay, there's something wrong. Value, we have value in. Oh, we don't have this here, sorry. I guess that's the problem. Let me see here. No, not out normal, sorry, it's just been normals here. There we go. So now we look at the normal thing. And this is also quite useful. But, and we see we get rid of these things, but we don't really get the nice outlines everywhere. So what we're going to do now is we just want to multiply these two. This, and we're going to multiply this. And then we're going to take the product and fit it and plug it in here. So what we get now is we get rid of these awful kind of Fresnel things. And we might want to tweak the values here a little bit. So maybe we bring this down further. Maybe do 0.05 and we bring this up to maybe 0.1. There you see, start having quite nice outlines. We actually get, yeah, we get nice things. And of course we can change the ray variance, the samples and everything to tweak this to our likings. And this gives you a good introduction, I think, to the Gather and what you can do with it. And it opened up, if you do custom shading things like toon things, 2D things, things like I do quite a lot. This opens up, or not, yeah, we do here at least quite a lot. Not always me. But yeah, this opens up a quite nice possibilities. And you could, of course, then integrate this to a toon shader quite simply. You can just pretty much do a Lambert of the regular one and put that into a ramp. And yeah, the rest is easy. This is the hard part. So yeah, that's it. Hope you like this and have some kind of usage for it. I myself have taken quite a lot of time to get this working. So I would love if there were a tutorial like this when I started with these things. So thank you. Bye.